Chapter 6 Brakes of TR-06555 Railway Rolling Stock Edition 4. Chapter 6 Brakes. All railway equipment with the braking system had been operated with the compressed air supply for the locomotive or hand by hand with the coupler. When they are coupled together, the locomotive and the locomotive engineer can operate the air brake system on all cars of his cab that regulate the braking pressure, gradually slowing the train in an emergency. He can apply full pressure to stop the train as quickly as possible. The conductor riding the caboose has a valve in which he applies the emergency pressure of the braking system. Handbrakes, however, the necessary becomes the cars are not always connected with the locomotive. Consequently, you have no source of oil pressure to work with the air brake system. Cars sitting on the side, waiting to be repaired, unloaded with the car. Even the brakes applied with the manually operating the handbrakes when the cars have been switched in the yard. They are often pushed in the switch engine until they gain momentum. They're rolling free with the yard crew. You can use the handbrake to their speed them, stop them when necessary. What kind of equipment is used to perform the braking function? Section 1 explains the equipment operation. Some of the more common air brake systems. Section 2 describes the handbrake. Section 1 air brakes. In this section, the three types of air brakes discussed: the straight air brake, the KC system, and the AB system. Several other variations of air brakes in use. There are three or more are most common. Each type is discussed in order. Straight brake, air brake. The simplest air brake system will be activated with the charge of the air locomotive brake. Straight, the brake cylinder of each of the air, the compressor, the held and supply server reservoir with the locomotive, the control valve, and the locomotive cab compressor for the air brake pipe directly to the brake cylinder for each of the car. The air pressure of the braking apparatus can be maintained exhausting the air, and the brakes can be released. The air compressor from the locomotive must recharge the reserve after the prolonged application of the brakes. The system is now obsolete and rarely in the United States except on some electrical railways, cars and automotive truck and buses. The KC air brake. Although the KC air brake system diagrammed in the figure 6.1 no longer accepted in interchange services in the United States, much of the Army-owned rolling stock overseas is equipped with it. The system has brakes cylinder attached directly with the auxiliary reserve under the car. The pipe running with the body of the reserve connects the brake cylinder to the KC triple valve, which is connected with the opposite end of the reserve. Actually, the valve has three pipe connections: one of the brake cylinder, one of the auxiliary rail, one for the branch pipe. The valve operation with one of the three ways responds to the increase or decrease of the air pressure of the branch pipe and charges the auxiliary reserve, opening the line into the branch pipe applies to the brakes, allowing the compressed air in stored in auxiliary reserve to flow in the brake cylinder and release the brakes and by allowing the air to brake cylinder to escape into the atmosphere. This shows your hose, angle cock, branch pipe, cutout cock, dirt collector, K-type triple valve, variable release, auxiliary reserve brake cylinder, and release valve. 6.5. The AB brake system. Most of the freight cars are now equipped with the air brakes. AB brake system is down figure 6.2. The comparing of the 6.1 and 6.2, you can see the reserve valve is reserved the valve of the brake cylinder and the mount is separated with the AB rather than together as the KC. Note also in the AB system, the reserve under each of the car divided in two parts with a separate plate. One side of the auxiliary reserve and the other side emergency reserve. The AB, like the KC, the triple valve that performs the three basic functions: the charge of the reserve defects the brake cylinder to apply the brake cylinder exhaust for the system of the release for the instead of the pipe connection that it has for one of each of the side of the reserve, one of the brake cylinder to release the control container, one of the dirt collectors on the branch pipe. The A brake system has several advantages to the KC system, and it provides a quicker application release of the brakes and capable instant emergency application of the brake that increases the braking ability up to 20%, and has an air filter with a triple valve that catches the minimum particles of the dust trapped in the dirt collector. The final advantage is the prolongs the time between the maintenance overhauls. 6.6. Noting the parts of the brake system. Know that the three basic air brake system have been discussed generally. That find out the names, location, functions of the parts that they make up each of the system. However, before beginning, let's narrow the field to the two system, eliminating straight air brakes. The system and the simple the view of the parts compared with the KC and the AB system. The other two systems must be complicated, but the main involve many and parts. The most important discussed in the following subparagraphs are the following. These discussed in figure 6.1 and 6.2. The train line combination of the hoses and pipes when they're coupled together at both ends of the car. The continuous air line of the locomotive reserve air supplied to each of the end of the train at each end of the line on each car. The section flexible hose connected. A hose connection of the coupling is attached to make it with the other cars. The angle cock is the two-position valve that is open with the handle of the parallel to the train line, closed with the handle turned to the crosswise right angle of the train line. When closed with the air pressure is the main line stop throughout the train angle. All angle cock must accept one of the most last car. The angle cock on the end of each car is usually positioned between the flexible hose and the pipe on each of the train line. line. The handle locking in both open and closed position must re-raise slightly before it can turn. It prevents the valve from accidentally opening and closing while the train is in operation. C, the branch pipe of the branch line. T is the joint in which the individual car air braking apparatus is connected to the train line. Here you see your standard 1 1/4 inch pipe nippling long with a following with a branch pipe to branch pipe T, a dirt collector, branch pipe cutout cock AB valve running into a emergency reserve pipe to the 2-compartment reserve. Also from the AB valve you see an auxiliary reserve pipe to the pipe retainer to the release control retaining an alternate method shown in the dot and dash lines. Also from the AB goes from the branch pipe to the branch nipple and the hose and its other coupling. Also from the AB to the brake pipe cylinder, the brake cylinder. Brake pipe T and the brake line, branch line T, the joint will individually car air braking apparatus connected to the train line. The cutout cock of the valve on the branch light permits the car to be cut out of the train air braking, which still allows the flow of the air to the train line and further the rear of the train. This value is normally positioned at the side of the car beneath the side sill that is easily reached by the trainman. When some of the part of the car braking system is inoperative, if the car is already coupled in the train, it is desirable to cut the car from the train braking system. The regulations controlling the number of the cars inoperative brakes. The permissible train. The table V6 shows how many cars inoperative brakes are permitted with the trains of the various lengths. The direct collector in the KC system is connected with the branch line as near as possible with the KC triple to the AB system. It's combined with the cutout cock and the attached directly with the AB valve. The direct collector is designated with the trap, dust pipe scale, and any other foreign matter that may be airlines is bottom part of the removing easily clean. The triple valve has been discussed previous paragraphs. It controls the flow of the air of various parts of the car's braking system. That recognizes the change in the air pressure. The air reserve of the railway car equipped with the KC air brake is known as an auxiliary reserve. It was discussed previously with the air reserve on the rail car equipped with the air brake AB brake of the dual compartment reserve. One side of the auxiliary reserve contains compressed air supplied with the brake cylinder. Normal side of the application of the brakes. The other side of the emergency reserve contains compressed air for air increasing the brake pressure into the emergency air changes, releases, and from other both of the reserve and control type triple valve. This shows the number of the cars and trains in your maximum car and operative air brakes. From 6 or less to 0 to 140, 147, 46, 221 effective air brakes. The release valve attached with the AB valve to allow the air pressure to drain from the auxiliary reserve alone with from auxiliary emergency reserve connected with the valve extended with both sides and near the middle so that it can be handled operated when the rod is pulled and away from the extent of the travel release with the auxiliary reserve alone. When it is pulled away out of the exhaust bolts inside the reserve, the KC brake system has a release valve with also operated by rods. The release control retainer is valve located at the end of the car vicinity of the handbrake used to retain the brake cylinder. The varying periods depending on the position of the hand that was the reserve of the recharge is used mainly on the monotonous territory of the position handled regulated manually on the member of the crew. J. The brake cylinder contains a spring-loaded piston and piston rod. When the air pressure enters the cylinder, the piston pushed outward against the spring tension forcing the piston to move the outward. When the air pressure is exhausted, the spring returns to the original position, pulling the piston inward, thus releasing the brakes. K. The live cylinder lever is connected with the piston rod to the cylinder lever rod. The floating lever in the top of the rods. When the piston rod moves, the live cylinder lever actuated to transfer the motion of the pressure through the other rods. Lever to the live truck lever is discussed in 360. One of the end of the live cylinder lever is the handbrake is attached. However, the rod is part of the manual braking apparatus discussed in the next section. 6-7. Each railway car is equipped with its own individual braking system. Each of the cars have a straight air braking system and the sole air supply located on the locomotive. Later, the cars are equipped with a reserve and valves operated automatically variations of air pressure. The first of these was a KC system with the triple valve auxiliary reserve brake cylinder connected in one unit interchange to the service in the United States. The AB system has replaced the older KC system, which modified more than an efficient triple valve with a dual compartment reserve comparable of strong air pressure emergency application of the brakes. The AB system has been a triple valve reserve brake cylinder mounted but separately, although main airlines and train lines must be connected. All cars and individual car braking systems can be cut out. Regulations govern the number of the cars per train may be cut out or have inoperable brakes. Section 2, handbrakes. All railway cars must be equipped with some meaning of slowing down or stopping the car by the hand. When the cars are being switched with the railway yard, frequently in motion, the locomotive can couple the handbrakes are necessary to train or control their movement. Through requirements are placed on the handbrake that may be capable of stopping the car. Must work in the harmony of the airbrake system. You remembered earlier in the chapter they explained the handbrake at the rod is connected with the live cylinder lever, which is connected to the piston rod. The handbrake apparatus was always located on the end of the car toward the piston rod at the pointing of the connection with the live cylinder level. The handbrake apparatus can actuate the brake system through a system of rods. The levers used in the airbrake system. Several types of the handbrakes in general. All types that consist with a hand wheel or a hand lever, handbrake shaft, handbrake rod, handbrake chain connecting the shaft with the rod. These are parts included in Figure 3-4. The illustration shown in brake rigging on the four-wheel truck. Handbrakes are classified either horizontal or vertical. Either classification may be one or two types, straight shaft or gear. The classification handbrake depends upon the position of the hand wheel and its horizontal handbrake classified in horizontal and vertical is classified in vertical. The two types are discussed in the paragraph that follows. 6.9 straight shaft. The typical straight shaft handbrake has a handbrake lever connected directly to the vertical handbrake shaft, which is anchored at the bottom of the end with a bracket attached to the underframe illustrated in 6.3a. The chain is attached with the vertical shaft, which is around the turn of the handreel as the chain winds onto the vertical shaft. Forces applied by the handbrake. Consequently, the live truck lever actuates the other rods. Levers necessary to apply the brakes near the top of the vertical shaft. Near the gear and the pawl arrangement holds the shaft in place with the position to which it is turned of the pawl. It fits into each of the tooth. The gear shall be turned to unwind the chain release. This shows the gear. 6.10 the gear. The operation of the geared handbrake similar to the straight shaft. However, the installed with the handbrake winding around with the vertical shaft. The system of the gears is employed with the bottom of the vertical shaft. Illustrated with the 6.4 typical figure. 6.4 gear handbrake provides a smoother operation, more easily controlled by the person operating with the brakes. The gear on the end of the vertical shaft of the pinion is meshing the gear attached to the shaft upon which the chain winds and unwinds. The gear turns. This is the gear type. 6.11 handbrakes are mandatory equipment for all the railway equipment that operated manually, provided with the means of slowing, stopping the cars that works in conjunction with the airbrake system. Handbrakes are used primarily training men when the cars are being switched in the railway yard, classified as either horizontal or vertical depending on the position hand wheel on the two types of gear. Handbrake provides smoother operation that does not straight shaft. However, other operation types is similar. Chapter 7 Safety Appliances.